Hey guys, this is part 2 of your conditional probability video, just to show you other ways you can see conditional probability besides the two-way tables. So remember, conditional probability contains a condition that limits the sample space. Essentially, you're changing the denominator in your fraction. You're not using the total people or the total things in the survey. You are making it smaller based on whatever condition you're given. It's the probability of event B given the probability of event A. And then once again, as our formula, I'm given event A. That means my denominator is only going to be the amount of numbers or outcomes in A. And then in the numerator, I put the probability of A intersect B, which is the probability of A and B. So this amount here. So in the last video, we showed examples using two-way tables. Here's going to be a couple other ways we can use conditional probability. So the Venn diagram represents students in a class that were asked what kind of pets they owned. Circle A is dog, circle B is cat, circle C is fish. Focus on this number out here, this 6. Remember, it's possible to own animals besides dogs, cats, and fish. Those people are still included in the survey, or these 6 people could not own any pets at all. So for A, find the probability they own a cat given they own a dog. So given they own a dog, the circle dog is circle A. So when I highlight this circle, I have 26 numbers in there. If I add 3, 7, 8, and 8, that's going to give me 26. So that's going to be my denominator. And then in my numerator, they own a cat. Owning a cat is circle B. So I want to highlight the part that's already in yellow that's also in circle B, which would be these two numbers here, 7 and 8, which is 15. 15 over 26 can't reduce. So that's our final answer. Now, the second part here, find the probability of A union C. There is no condition in this example, which means my denominator has to be the total. So the first thing that I want to do is I want to total all these numbers up. Which is 56 total. Now remember, U for union, that means everything in the circle of A, everything in the circle of C. So I go through, I highlight all of A and all of circle C, which is going to be 42. Now from here, I can go through and I can reduce this down to 3 over 4. So remember, unless you have a condition, you want to do the total here. There's nothing that tells me I have a condition, so I have to use the total 56 people that were surveyed. Second example, the table represents the sums found when rolling 2 dice. Find the probability of rolling a sum that's a multiple of 3. You have one event here and no condition, so all I do is highlight everything that's a multiple of 3. Remember, multiple of 3, 3, 6, 9, 12, 15, 18, etc. So I have 3. 10 numbers that are multiples of 3 out of the total 36, which I can reduce down to 5 over 18. Find the probability of rolling an even sum or a sum greater than 9. Once again, I have no conditions here limiting. All I want to do is focus on the even sums, or, which means I have two events here, sum greater than 9. So I'm going to go through, I'm going to highlight all my even sums. So 18 over 36. And then I'm going to highlight all my sums that are greater than 9. Which is 6 numbers. Now what you should notice here is that I no longer have just yellow and blue highlighted. I also have this green area, which means I've counted those numbers twice because they are even and greater than 9. So you want to make sure you subtract those 4 numbers that are highlighted in green because this is an example of overlapping events, which reduces down to 5 over 9. Remember, anytime you work through probability, it's not going to tell you, well, these are just examples of overlapping, mutually exclusive, conditional. You're going to have to determine what the difference is. That's why we're going to keep including these other examples of previously learned material. And lastly, find the probability of rolling an odd sum if it is known that one of the dice lands on a 3. If it is known that one of the dice lands on a 3, this is a condition. One of the dice has to have a 3. So I'm going to go through. If it is known one of the dice lands on a 3, I have the column here of having a dice that lands on 3. Now, the thing you have to be careful with here, this 3 here, this column, there are 6 numbers in it. In this row, there are 6 numbers in it. But because they meet here, you want to make sure you don't double count this number. So instead of having a denominator of 12, we actually have a denominator of 11. Now, of those 11 highlighted numbers, how many are odd? Well, that would be this 5, 7, 7, 9, and 9. So that's our condition. Has to have a 3 and also be odd. So of these 11 numbers, 5 of them are odd. Sorry, 6 of them are odd. Our probability is 6 over 11.